didn't work. All right, so we're going to move on from here. We're going to say next task. All right, so now we're looking at, well, actually, sorry, where are my manners? Let's talk about what the function is asking. So it's asking this.
Given a year, return the century it is in. The first century spans from the year 1 up to, and including the year 100, the second from the year 101 up to, and including the year 200, etc.
Okay, great. So y'all know about centuries. We're in the 21st century right now. If we look at these examples, we got 1905. That year was in the 20th century. If we look at 1700, that was considered the 17th century. But 1701 would be the 18th century. Okay, so basically, there's kind of a relation here, 1700, 17. Those two are sort of related to each other. So we can maybe just do a bit of math here. I mean, we looked at adding numbers in the last one. So let's say, well, let's just go right for a return here. And we'll say return year divided by 100. Let's see where that gets us. So we'll run the tests, and what's that saying? 3 out of 9. Okay, so I actually wasn't expecting to pass any of them, but it did get some of them. So this one was off. It was 19.05, but this one, the 1700, divide that by 100, you got 17. So that actually did solve the problem. And in this one, 2000, yeah, 20th century. 200 was in the 2nd century. So all of those were correct. Where it's breaking down is some of these other ones where we've got, for example, 1988. It's saying 19.88. Okay, so maybe we want to round this, like we want a whole number value. We want an integer value, but we're getting these decimal numbers here, these floating point numbers. So we're going to round this, and this is kind of our introduction to the math library. And actually, let's make a list of that again. So topics, we want to talk about the math library a little bit. We want to talk about rounding, and we're eventually going to talk about this Modulus operator. Just because it kind of fits in here a little bit, and it's something we're going to be using a lot. So year divided by 100. That wasn't working for us, so now we're going to round this thing. So JavaScript has this built-in library. It's called Math, and it's used for doing a lot of math things. Math.round is what we're going to use first of all, because we want to round this value. We're going to try running it, and we'll see where that gets us. So, okay, now we're passing 5 out of 9. That's better. It's not perfect, but it's better. So let's look at the differences. So this one's still not passing because it's just giving us 19. So at least it's a whole number value, but it's not really the right whole number value. If we look at this one, 17, well, that one was right before. 1988, okay, we're getting 20 from that because it's basically 19.88. It's rounding it up to 20. That one was working before. This one was working before. This is newly working, so that's good. But this one not working. That one not working. Maybe we can try to pick out a pattern here. 2001. Really, we should be getting 21. So it seems like our rounding, it's not really perfect. We're not always rounding in the right direction here. So there are a few ways that we could adjust this. We could say right now, basically, if we had, let's do a visual for this. So we'll trash this, and yeah, I'm sure. So if we had kind of a number line here, a perfectly straight number line, and we had, let's say, the year 1900 over here, and then the year 2000 over there, then basically, if we wanted to talk about how this is all going to get rounded, any number that's in this range is going to get rounded down to 1900, and that's going to go all the way to 1949, whereas anything beyond that, so from 1950 to 2000, it's going to round it in the other direction. It's going to round it up. Okay, so there are a few ways that we could sort of fix this. I mean, the first thing that we could do is we could maybe try to shift the goalpost here a little bit and say, well, okay, if it's not working there, if 1949 is sort of the cutoff point, then we sort of want to move that along. We want to move that in this direction. So we kind of want to move it, I guess, 50 units to the right. So let's try adding 50 to the number. So instead of year divided by 100, we'll do year plus 50 divided by 100. You'll notice we can kind of nest things like this using parentheses. So that's the same as writing like year plus 50 and then having all of that divided by 100. That's the same thing as what we're looking at over here. Okay, so let's see if this works, first of all. How are we doing? 6 out of 9. We're not doing great. So this one is actually rounding up to 18. We don't want it to round up to 18. We want it to round to 17. It should still be rounding down. So maybe we actually added too much with this 50. Maybe 49 would have been a better fit here. So let's try that. We'll see if it works. Okay, so that actually is passing all the sample tests, but we sort of had to do this extra thing in here, and I mean, it worked. It's not horrible, but maybe there's a better way we could do it. And yeah, there is. So basically, instead of adding 49, we're basically just going to tell it specifically the direction that we want it to round in. So we've got a couple other math library features here. First one I want to talk about is floor. And this is kind of a math concept as well. Floor, it basically just means you're going to take that decimal number, you're going to round down to the nearest integer. So 1905, or that was 19.0. Hey, I've got an idea. We're going to be able to show kind of how this function is working a little more. So we're going to say var century decimal. I'm giving that kind of a long name. You can make your variables whatever you want, but if you can make them something that kind of speaks for itself and gives the reader an idea of what it represents, well, that's probably a nice thing. Okay, so century decimal is year divided by 100, so I can just put century decimal in here. The thing is, I'm running that, and it's still just going to give me the final value. It shouldn't really be any different from what we had before, right? We've got 19, it's rounding down. But now, since I want to see both, I'm going to do a console log. This is a really useful thing for you to get into the habit of. Basically, anytime you want to reveal some information about the problem, we're going to do a console.log. So when I run this, this isn't going to affect how the function itself works. It's just going to give this extra little console output. And this is something you'll use if you end up making websites, web apps, anything like that. We're going to make heavy use of the console. So this is a really good thing to sort of get into the habit of. All right, so we've got our console output. It's 19.05, and then we can see that when the Math.floor runs, it's making it just regular 19. If we look at this one, it was 17 anyway, so it rounds down to 17. No difference there. Looking at this one, 19.88, it's rounding down to 19. Really, it should be rounded up. We'll talk about how to do that in just a sec. But even something like this, 20.01, I mean, yeah, that's rounded down to 20. We want to round it up. So basically, the idea is that instead of using floor, we're going to use ceiling. So in JavaScript, we're just going to use ceil. Just like that. Okay, so now we can sort of see not just what it's outputting, but like where it's coming from. So it's saying 19.05. We're going to ceil that. We're going to do ceiling on that, and we're just going to round it up to the nearest whole number, which is 20. And this seems like it's working for every single one of our test cases, so that's probably a good sign here. We could probably delete the console log. Again, it's not the sort of thing that's going to make like a big difference in terms of performance time, but it's not negligible. I mean, it is, well, okay, in this case it's negligible, but if it was in the middle of a big loop or something like that, if we were really outputting some heavy stuff, it's another thing that the computer has to do as it's processing this function. So, we can try to minimize that as much as possible. Now, before we finish up with this one, and I mean, this should work. In fact, even if we sort of get rid of this century decimal thing and just put that in there, This should work now. And again, we saw in the last one, like there are other ways that we could write this. So maybe I'll just delete this now and submit it. And that should work just fine. But yeah, okay, great. Thank you. Appreciate it. But there's one more thing I want to talk about here. So it's this modulus thing. It's kind of a subtle but important difference between this dividing by 100 and getting the result of that division, which like we saw over here, 19.05. It's the difference between that and we'll use this percent symbol. This is the modulus operator. It's going to do that division, but instead of returning the quotient, the result of the division, instead, it's going to return the remainder, which is kind of a neat thing. So basically, if we try to divide 1905 by 100, it'll go in 19 times, but then there's going to be a remainder of 5 at the end. So we're getting that 5, which is kind of cool. So that's actually sort of useful. I mean, we could do something like this. We could do... Okay, let me do this one step at a time. So I'm going to say var remainder is assigned the value of year mod 100. So we have our remainder now, and then we could do something like return year minus remainder. So let's try that. Okay, great. So now we've got this 1900. We've basically subtracted the 1905. If we look at this one, well, it was 1700 to begin with, so the remainder is 0. It's subtracting 0, so it's just 1700. So we're kind of getting to the nearest 100-year mark each time this way. But it's not really the right one. We kind of want it to be more like 2000 in this case. We want this one to be more like also 2000, I guess. So we're going to add 100 to that. All right. So 2000, if we look at this one, that's also 2000, which is good. 2100. So that could be an issue. I mean, we were pretty close here, but again, if we try to divide this thing by 100, it's still going to have some issues with this. There's those 3 cases where basically it was right on already, and by adding that extra 100, we're kind of undermining that. So if we wanted to really make this work using an algorithm like this, we'd have to build in some ifs. So we could say something, actually this is a good opportunity. We have conditional statements in JavaScript. Well, pretty much every language is going to have conditional statements. It's kind of like if this is true, do this. If it's false, do something else. So we're going to say if remainder equals 0, and then we're going to talk about what we'll do there. So if we look at the syntax, first thing to notice, there's 2 equal signs here. As opposed to just the 1 equal sign over there. And this is kind of this is where we distinguish between the math equals and the programming equals. We would actually say this is an equality symbol. This is an assignment symbol. And you're probably noticing by now, anytime I'm doing these variables, I'm not saying remainder equals year mod 100. I'm saying remainder is assigned the value of year mod 100. I'm not saying that that year mod 100 is always going to be the same as remainder. I'm not saying this is always going to have this value. Basically, the idea is we're assigning the value. We're pushing this into the value that remainder is holding. So basically, remainder is going to have this value, and then over here, we're checking to see if it's equal to 0. So if it's equal to 0, we're going to do this one thing over here. If it's not equal to 0, we're going to do something else. And the way we specify that is with else. So this is nice, really semantic syntax here. It's very clear what it's talking about. If this, do this. Else, do this. So basically, the way this is going to work is we're going to do this if true, and then down here we're going to do this if it's false, if it's not true. Okay, so I mean, that's pretty much it. That's our conditional statement. So what do we want to do here? Well, basically the idea is that if the remainder is 0, then we're just going to return year divided by 100, because we found that that worked for us. That was That was totally fine. And then I'm just going to copy this over here, and we'll do this if it's false. So if there is a remainder, then it is going to subtract out that remainder, add the extra 100, and then divide by 100. Okay, so I'm going to run this. Okay, and now look at that. It's passing. It's passing all the tests. So basically the idea is if it's one of those full value, like if it has no remainder, 1700, then it's just going to divide that by 100. We've got 17. Now if it's not, if there is a remainder, like in this case the remainder was 5, and I guess I could have console logged that if we wanted to actually see the 5 in there, but the main thing is that a remainder is 5, so it's actually saying, oh, well, that remainder is not 0, so we're not going to execute this, we're going to execute this instead. And that's taking our remainder year minus that 5, so that brings us to 1900. We add 100, we get 2000, divide by 100, we get 20, and it works. So is this better than our previous algorithm? That's a good question. Probably not. It's not necessarily easier to read this than it was to read the previous one. So I'm mainly using this as an opportunity to just sort of demonstrate some other tools, some other ways we could do it. But the thing is, I also wouldn't say that this is really a worse algorithm than the other one necessarily, because it's not too complicated. It's not like it's taking up a lot of extra computation time or anything like that. It is still relatively fairly clear for the reader. So it's not necessarily worse to do this. Look, there's more than one way to solve a problem. That's the main thing. Use whatever way you want. Okay, so going back to this, there's one more thing I want to say about this if-else business, and it's this idea you might remember that as soon as you return something, the function ends. So basically, if the remainder equals 0, it's going to return this thing, and it's not going to get any further than that. It's not going to get to this last line. And in fact, even with else, it's not going to get to this last line. But it also means I kind of, in some ways, don't need the else, because basically if the remainder is 0, it'll finish right here. The function will end as soon as it hits this return. So it's not like it's going to get to this part anyway. So if I run this, it should still work exactly the same. It's passing all the tests. Okay, so then that's a little nicer in some ways, and this is kind of a setup, a kind of strategy that we'll use a lot in the future. If we wanted to make this look a little nicer, if we wanted to sort of clean it up a little, gulp it down, one thing I'll point out first of all is that this is just one line. Our if statement is just one line, and when it's just one line, we actually don't need these braces or anything like that, so I can just delete these and have that there, and it should still work the same way. So there we go. I mean, I don't know if that's really better or not. Like, maybe it's making it a bit harder to read, so maybe that's not better. I don't know. That can be for you to decide. But anyway, all I'm trying to say is our function, it could look like this. You know, it could be 3 lines long, or it could look like what we had before, centuryFromYear with an input of year, and we're basically just returning Math.ceil of year divided by 100. And in fact, you remember, like we were talking about before, we could even make that more efficient and say centuryFromYear is just going to be a function that takes an input of year and produces an output of Math.ceil year divided by 100. And so basically we can make it as small as this, you know, like this could be the whole thing. That could be our function. This is saying and doing pretty much the exact same thing as this. Again, there are some subtle differences, but it is pretty much the exact same thing. We saw that this worked. Let's clear it for a sec. We'll see if this one works. And yeah, it works just the same. So we could do it like this. I'll just I'll comment this out for now, but I'll leave it in there. It's a more efficient way of doing it. Well, okay, it's more space efficient. It's a more terse way of doing it. It's not actually computationally more efficient. It's probably going to take about the same amount of time to run this as it would to run this. And both those times are like negligible. You know, these should not take a long time to compute. Okay, just one last thing that I wanted to say here. Just like I was saying, how we get to decide on what we name our variables, we can kind of make that decision for the parameters as well. We don't need to call it year. Like, from the point of view of the code here, it's basically saying, well, in this case, year is 1905. It's getting the first input is 1905 here. It doesn't care if you're calling it year or if you're calling it something else. We could call it just the letter Y, and then, well, this wouldn't work because it's going to say, no, what the hell are you talking about? What's year? So whoops, we do need to replace all these years with just the letter Y. And if we were working in a text editor or an IDE or something like that, we would be able to Control F this kind of thing. So there we go, finding the place. So it's still working. We can call these parameters whatever we want. We sort of have control over them in the same way that we have control over our variables. And again, we do sort of want to be calling it something fairly semantic, something that's going to make sense to the reader, so that someone could look at this and say, oh yeah, I get that. So year is probably a good thing to use as our name for the argument, just like remainder is a very clear thing in terms of what we're actually doing there. Okay, we're done this one. We're going to submit that, and just to sort of save it, I know we already submitted one before, but we want to save it so that if anyone wants to take a look at this later, they can see two solutions. Great. All right, so we'll move on to the next task now, and this next